Okay, we're going to look at the parametric second derivative and just do a quick example leading us to the general formula for finding the second derivative of any parametric equation set. So here we have x of t equaling t cubed and y of t equaling t to the fourth, easy examples. If we were to find the first derivative for this parametric curve, we would be finding dy dx, and we know that's found first by finding dx dt, which in this case would be 3t squared, and dy dt, which would be 4t to the third. Dy dx is found then by dy dt over dx dt. We know that, it's no problem. Dy dt is 4t to the third, dx dt 3t squared, and that is simply 4/3 t. Easy peasy. Do not think that the second derivative parametrically is equivalent to the second y derivative with respect to t over the second x derivative with respect to t. So, not equal to, no. This statement that I'm circling is true, that the second derivative of the parametric equation is not equal to the second derivative over the second derivative. That is true, they are not equal. So what are they equal to? Well, without just throwing the formula at you, let's just find the second derivative of 4/3 t. But it is the second derivative with respect to x. So we are simply going to ddx 4/3 t. From our work in chapter 4, we can just differentiate this, implicitly, giving us 4/3 t prime. So question, what does the t prime represent? Well, when we did this before, we knew that the prime represented d dependent over d independent. Well, we know since we're ddxing right here that t prime must be equivalent to dt dx. Now keep in mind that that is the reciprocal of dx dt. So dt dx would be 1 over 3t squared. So continuing with our implicit derivative, we have 4/3 and then this times 1 over 3t squared, giving us 4 over 9t squared, which is the correct second derivative for this set of parametric equations. Keeping a close eye on this right here, this 4/3, doesn't that look like the derivative with respect to t of that equation? It is. It is ddt of dy dx. And this here is simply dx dt. So if we rearrange what we did, we could say that the second derivative is equal to the derivative with respect to t of dy, it just doesn't look right, dy dx over dx dt. That, by the way, is the correct parametric second derivative formula. And notice, it is not like the second derivative over the second derivative. It comes from this process of implicitly differentiating dy dx, which we know is going to be a t function. So the implicit derivative is going to result in this. And this is weird. It's going to get you the reciprocal of the dx dt, which is why in the simplified formula down here, dx dt winds up in the denominator because you wind up multiplying by dt dx if you do it implicitly. So that's a wrap. This formula here is the correct second derivative parametric formula. So brain tattoo on that one. Tori out.